Hi all, this is guided practice 18, the 5.2, 5.3 exponential functions. So we're going to start out here by graphing our 4 to the x, so our x and y table. And I want 0, 1, and 2, -1 and -2. When you plug 0 in for your x here, you're going to get 4 to the 0, which is 1. When you plug in 1, that's 4 to the 1 is just 4. When you plug in 2, that's 4 squared, which is 16. When we get to -1, it's going to look like this, 4 to the -1. And that negative means it's in the wrong spot. So you want 1 over 4, which would be 0.25. Then for 4 to the -2, you want 1 over 4 squared. And that's 1 over 16, or 0.0625. So we have those as our values to graph. So when I graph those, we're just sketching here. So at 0, 1, I get a point. At 1, 4, I get a point. And at 2, 16, so somewhere way up here. And then I get 1/4 and something super close to 0. So it looks like this. It never crosses the x-axis, never goes below it, okay? So it's never equal to 0 and it's never negative. Number 2, we want a cell divides into 2 every 20 minutes. Write an exponential function that models the number of cells after x minutes. So we think about time, so t, and the number of cells. Well, they want our minutes to be x, so let's switch our t to x. And I'm going to call this cells, but really it's our f, right? Our f of x. So at time 0, we have 1 cell, and it's going to divide into 2 every 20 minutes. So after 20 minutes, that 1 divides into 2. After 40 minutes, the 2 that I had at the 20-minute mark are going to split into 2, and I'm going to end up with 4. At 60 minutes, my 4 becomes 8. At 80 minutes, my 8 becomes 16. At 100 minutes, my 16 becomes 32, so on and so forth, okay? So what we want to see here is that in the bottom, these are powers of 2. So this is 2 to the 1, 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th. And this one, the 1 would be 2 to the 0 if I'm following the pattern, okay? So that means for my function, I'm going to get 2 to some power that corresponds. Now, take a look here. The 0 and the 0 are the same thing. I want to somehow do something with the 20 and get 1, with the 40 and get 2, with the 60 and get 3, with the 80 and get 4, with the 100 and get 5. So in each case, what I'm doing to go from 20 to 1, 40 to 2, 60 to 3, I'm dividing by 20. So if I take my x value and I divide it by 20, I get the power on the 2. So that means that my power is going to be x divided by 20. And that's going to represent the number of cells after x minutes. Number 3, a banker offers a 5% annual interest rate for new customers who invest $10,000 or more. How much will a $17,000 investment be worth in 2 years? Now we're going to assume here, typically banks compound monthly. That was my miss. I did not type that out to you. It will always tell you how they want it to be compounded. Okay, so if it's compounded monthly, we're using the 1 plus formula. If it's compounded continuously, we're using the PE to the RT formula. So because it's compounded monthly, we're going to use the A equals P times 1 plus R over N to the NT formula. Your P is the 17,000. Your R is the rate as a decimal. So 5%. To convert to a decimal, you would divide by 100, which turns out to be 0.05. Your N is the number of periods per year that it's compounded. So if it's compounded monthly, there are 12 months in a year. So my N is going to be 12. And my T is the time since you invested, and it's asking for how much it's worth after 2 years. If we plug all that in, we get 17,000 times 1 plus 0.05 over 12 times 12 times 2. So that's what I'm going to calculate. So if I'm putting this into my calculator, I'm taking 0.05, dividing it by 12, adding 1, raising that to the 24th power, because 12 times 2 is 24, and multiplying that by my 17,000. And I end up with an A equals $18,784.00. So in those 2 years, you gained almost $2,000, $1,700. Okay. For number 4. All right, now we've got an exponential equation here that we want to solve. In order to do that, I need the two bases to be the same. Okay, they're not right now, right? 9 and 3 are not the same, but 9 and 3 are kind of related because 9 is 3 squared. So if I replace that 9 with a 3 squared, then when I take powers to powers right here, I multiply them. So this is 3 to the 2x squared. Now I do have the same base, and I can set my exponents equal. So I can make the 2x squared equal to the 3x plus 2. This is quadratic, so I'm going to move it over. So 2x squared minus 3x minus 2 equals 0. Let's see. We can factor this with box and circle. So we've got a 2x squared here and a minus 2 down here. And I'm looking for factors of -4 that add to -3. So that would be -4 and 1. And if I now factor the box, the top row, the 2x squared and the x have a common x. So I move it to the side. When I take it out, I'm left with a 2x here and a 1 in the second column. The bottom row, they both have a -2 there. And if I check, -2 times 2x is -4x. -2 times 1 is -2. And that means that this is going to factor as x minus 2 and 2x plus 1. And then I can solve each one. This one's going to give me x equals 2. And in this one, I'm going to subtract the 1 and divide by the 2. And those will be my 2 solutions. Okay. And lastly, we got 2 more. Graph y equals e to the negative x. 0, 1, 2, -1, and -2 when I'm graphing. Plug in 0, -0 is still 0, e to the 0 is 1. Then we're going to plug in 1, so y equals e to the -1 becomes 1 over e, and 1 over e is 0.37. We're going to go to 2 decimal places here. If we plug in 2, that gives us 1 over e squared. When you plug it into your calculator, that's 0.14. Now we plug in -1, negative and -1 becomes e to the positive 1, and that's just our 2.71. So if we round it, that's 2.72 actually when we round to the second decimal place. And then we're taking e to the -2, and that's e to the positive 2. Squaring e, we get 7.39. So those are the values that we have to graph. 0.37, 0.14, 2.72, and 7.39. Okay, and so if we graph that, it looks like this. At 0, we get 1. At 1, we get 0.37, which is pretty small. And at 2, we get something that's very close to 0. At -1, we're at 2.72, so here-ish. And then at -2, we're at 7, so up here. And connect your dots, you get that little swoop going down towards 0. Okay, so notice that the 2 ways that you can get something that decreases from left to right would be if your a is less than 1, or if your a is bigger than 1, but your exponent is negative. Then you end up with something that decreases left to right. Okay. And lastly, number 6, we're finding zeros. So we're going to set this equal to 0. And we're going to recognize that both of these have an e to the x here. They also both have an x, so we can factor both of those things out. So we have an e to the x that factors out and an x that factors out. When I take both of those out, I'm left with x plus 5. Now we know we set e to the x equal to 0, and we know that that never happens. Okay. Then we set the x equals to 0, and we get a 0. And then we set x plus 5 equal to 0, and that's going to give us x equals -5. Okay, so just factoring out that e to the x is how we solve.